This year we are doing something different in science. They are called PBLs. It stands for Project-Based Lessons. It is an interactive project. It is a good idea because it focuses on critical thinking, collaboration, and problem solving.
PBLs focus on 21st century skills. Some of these skills are critical thinking, collaboration, and inquiry. We use critical thinking by solving our problem and getting closer to our solution. We used collaboration by using our peers and working in groups. We used inquiry by asking questions.
Our overall question was, what type of structure would be most resistant to an earthquake? Before we started to answer the question, we had to know different terms.
The first and probably the most important term is base isolation. Base isolation is the separating a building from the ground to absorb some of the seismic waves. We find this term important since we needed a way to make our building earthquake resistant.
Seismic waves are waves of energy caused by an earthquake. And there are 4 types of seismic waves: primary, secondary, love, and Rayleigh waves. Primary waves move back and forth, secondary waves move up and down, love waves move side to side, and Rayleigh waves roll. These types of waves help us know how earthquakes in some locations move.
We also had to know plate boundaries, which is the point at which 2 tectonic plates meet. Tectonic plates are the puzzle pieces under the Earth's surface. A fault is a break in the tectonic plates when they hit each other. Both plate boundaries and faults are the cause of an earthquake. We also needed to know epicenter and focus. The focus is the central point. The focus is also the place of attraction, attention, and activity. The epicenter is the point directly above the focus, which is also the true center of disturbance.
After we learned about earthquakes, we had to pick our location and type of building.
We chose to do a skyscraper. Our location is San Francisco, California. We decided to model our building after the Bank of America building because it is the second tallest building in San Francisco.
We chose San Francisco because there are lots of earthquakes there. This is because of a giant fault that runs through California.
It is called the San Andreas Fault.
First, we had to build something that would act as an earthquake. We decided to use a piece of wood and springs. We put the springs underneath the board so that when we pushed the board down and released, it would move up and down.
We chose this design so that it represents Rayleigh waves. Rayleigh waves are a type of surface wave that moves in a rolling motion. So you would feel that up and down motion if you were in an earthquake.
The next step was to make an earthquake-resistant building. We wanted to use base isolation because it's something buildings use today. So we wanted to put small springs on the bottom to separate the building from the ground. We made our building out of connectable beams and columns. We felt that the columns and beams weren't too heavy or too light.
Later, we tested our structure against an earthquake. We wanted it to stay standing and not shake very much. Here's what happened. As you can see, the building stayed standing. It did shake a bit, but the springs absorbed some of the energy waves.
So, what type of structure would be most resistant to an earthquake? Our group thinks that any structure can be. We saw skyscrapers, factories, and bridges, and they all stood standing. So we think there isn't just one type of structure that's more resistant than the other. It just depends on how you build it.
So why is this important? We think that PBLs help us in deeper thinking. We couldn't go home and Google what type of structure is most resistant to an earthquake. We really had to take many steps to find our answer.
In conclusion, our earthquake-resistant structure worked. We learned many skills like critical thinking, collaboration, and communication. Finally, we learned ways to make an earthquake-resistant structure.
Break, glass, break, 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 drop like an earthquake.
Bloopers!
Finally.
We'll have to watch it.
Hey, I can be Austin.
Watch Blake closely.
Break, 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 drop like an earthquake. The glass break, glass break, glass break, 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 drop like an earthquake. Break, 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 drop like an earthquake.
Oh, dang it! Did you miss it? No, I accidentally paused.